Hi my friends, today we discuss about mold design. This was a suggestion from one of you, my friends. I start with this part, which is the result exactly as it was made in my previous tutorial number 204. I changed something here. You may wonder why when I apply home the part is placed here. Look why. Alt F I and I select another color, for instance forest. OK, and now you see here 2 points. When I made this sketch to place there the volume of the part, the points were included in the sketch. So now I delete this sketch, and now if I use the same tool, we see the full presentation. The first thing I do is to eliminate or suppress this fillet. I delete it to have no problems. Firstly, I change the view to be this presentation. You know the procedure. Set current view as home, fit to view. And now, no matter where I am, if I apply F6, I have this presentation. Shell with a thickness of 1.6, because this now is a solid body and I want it to be a shell. Okay, how can we see that this is a shell and not a body? We select half section view, we select a face, planar face from the side. There is another planar face on the bottom, but I don't use it. And you move this arrow to see inside. Yes, good. This is the first step. The next is to create a plane. Placed at -5 millimeters from the bottom, and we use this plane as a tool to cut the part. Split. The tool is this, and we use this solution to maintain both bodies. Okay. And now we see here solid bodies 2, not 1. This one I want to be hidden. It is hidden. And also this hidden. Good. This is the base of the mouse. Now this object must be suitable for extracting from the mold device. We have to create an angle greater than 90 degrees between this face and the base. We do this by using the tool draft. We select the second solution, and we have to select a fixed plane. This is a fixed plane. And now faces to have a taper angle, in fact. So I select all of them. You see here, automatic face chain, automatic blending. These both are checked. Yes, so I select this. Remember that this arrow was oriented up, and here you see what happens. This is the end of the arrow, so it was here and now is here. How is this angle? This angle is added to 90 degrees. This is at 90 degrees and this is greater than 90 degrees with 2.5 degrees. This is the default value. We accept the default value. Apply. Then we select again this face as a fixed plane and the other direction, because now we work outside. Yes, we see that this angle is the end of the arrow is on the sloped line. This is 90 degrees and this is the new orientation, the new angle of the outside face. Okay, we can verify everything by using the tool measure. M from measure, and we select this face and this face, and the angle 87.5 degrees. So we have a taper angle in this direction. Yes, this direction. And then we select the same face and the interior face, but not that. We select the only side face which is plane. This is, and here is 92.5 degrees, so that two are parallel. That two faces are parallel. Good. Escape. And this is the base. We open the other half, which is the lid. This is the base and this is the lid. I can write here, no problem, base and lid. Good. We apply not visible for the base and we keep the lid. Good. Now we know the procedure, so we turn back the part, we select this face because this is the fixed plane, the direction is good, and we select the interior face. So we have this end here, so it is good. Apply. Then the same face but the other direction, and we select the external faces. Okay, we can verify the angles. Measure this face and this face. The angle is 87, and this is good. Yes, the other is the same face here, but the internal, which must be 92 degrees, 92.5. Done. You have to verify this because you can make mistakes. We start with the base. Visibility and hidden. Here we want to create a lip along this contour. The lip is needed for combining plastic parts. To do this, we don't have here any tool for this purpose, so we go to the list of panels and we add the panel plastic part. You see, here are the 6 tools for plastic parts. One of them is lip. We select this internal contour and we show the pull direction. The pull direction is the axis Z. Yes, the axis Z, which is here. You remember this line was going to the origin. Good. And what? And we go to the other tab in order to select values here for that lip. The values are 10 degrees here and 0.6, you'll see why, millimeters. Okay, now you see the lip. Yes, this and this are new. Yes, this face and all around faces like this. Good. Next are 4 bosses which are to be placed here. The boss is this. You see, there are 2 kinds of bosses: head and thread. Head and thread of the screw or screws used for combining the parts. We create a plane based on the bottom face up -8 millimeters. We decide for 8 millimeters to be up for a sketch. What sketch? The sketch contains, like when you use holes, the sketch is one line horizontal here and restart, another one horizontal, not horizontal but sloped here. Good. Dimensions, but I like to change the view, the background. Alt F I and presentation. We go back to our background. I make this horizontal. Oh, this was not horizontal, the sketch. Now it is. We apply dimension, which is 33 millimeters. we place on the same vertical the midpoint of the new line and the midpoint of an arc here. The distance is 15 from the origin. 15. Project geometry. We project any arc of the three ones. We place the midpoint of this line right here. We draw a new line as construction line between the ends of this arc, not construction anymore, and parallel this new line with the construction line. The distance is 36, the length 36, and now we place points at the four ends. Here we place the bosses. Finish sketch, F6, and boss. The bosses are now here. We select head because we want to place screws from the back up. Yes, we want to place screws, introducing them from the bottom. Dimensions here are 1.6 tab 1.6 again, tab 0.5 is okay, 3.5 must be 3. Oh, not enter, but we can reuse the settings by placing here another diameter of 7.5 and tab 8.5 here. We select the other solution because we want to have this kind of countersink. Okay, not visible, and we have a very nice combination of holes and bosses to be used for this base. Good. We go now to the other object here, which is the lid. We hide the base and we work here. To work here and to have a correspondence between the sketch, we share the sketch. What sketch? This sketch. Share sketch. You see, the sketch is here now and is visible. And we apply again boss, the tool boss, but now we select thread instead of head because we want to make room for the screws to be threaded. Dimensions for the thread are 7.5 with 3 millimeters, 2 degrees, 1 degree, full depth. Full depth is to the face, not through the part. Okay, we can add ribs, stiffening ribs to stiffen the object. Let's apply 3 ribs with smaller dimensions, because you see it's too great for this part. 1 millimeter, 2.5, 2, 0. Okay, that's all right. Okay, now you see we have everything prepared for injecting in a mold device, because there are angles to be easy for extracting this part from the device. We now make this not visible, the shared sketch, visibility, and we must place here also the other contour, which is the groove. We do this by using again lip, but not lip groove. Path edges is this. Pull direction is again Z axis. You see that Z axis where it is, and we go to groove to place dimensions. 10 degrees is from the other, 0.5 is from the other, because they must be combined. Okay. Let's make visible the other part, the other solid, and now we see a gap here, because this is for this mouse. It has this gap actually. Let's see inside what happens inside. View, half section view, face, and we see everything inside. You see the two bosses, another one here. I move a little the plane to see inside. You see the screw is placed here, and it threads the thread inside the other part. When you use screws, they are inserted here. Okay, we have now a prepared part for creating the mold. Let's apply here fillet of 3 millimeters and plus another one here of 2 millimeters. Okay, now I remember that I forgot something. What? I forgot to add a radius here, 0.5, which is placed at the base here, a fillet around each boss. F6. The volume of this combined part is combined from two halves, is this one copy, close, and again I make a sketch here for you. With X to the right to apply the text. Okay, let's turn the part around and you see here the value. If you model this part of two solids to have all the data. Okay. I want you to know, my friends, that I'm not an expert in this domain. The field of mold design, as part of the technological development of recent years, is particularly complex but very beautiful. Look only to the glossary of terms. Absolute maximum melt temperature, absolute ramp speed, air shot, and we go further to see other terms. You see, there are a lot of specific kind of components, technology, skills of all kinds to cover this interesting domain. If we take a look also to the new strategy of Inventor, of Autodesk for Inventor, and we take a look here to the general enhancements and what's new in the Inventor 2022, if we go lower, we see something about Inventor Mold. The tools provided with Inventor for mold simulation, analysis, and material assignment are removed from release 2022. In addition to the material library being out of date, the analysis portion of the tool was 32-bit. Now everyone works with the 64-bit machines, and presented a possible future security risk. The following commands are removed. Select material. This was the first moment when you start the construction of the mold device, because you have to select a material for the part, and there are thousands of kinds of materials. This command or tool was removed. Part process settings, part fill analysis. This was also an important element of mold design, and so on. I was very confused with this, So I asked my friend, I can say, from Autodesk, and he told me a lot about this direction of Autodesk about using or not using Inventor mold. His name is Johnson Xue, and here is an excerpt from his email. As of Inventor 2022, some of the workflows in mold environment are removed due to security concerns. The newer mold technology and workflows are being worked on based on Fusion platform. I do not continue with presenting more about this, even if it is a very interesting domain, since the mentioned changes are foreshadowed. So, that's all for today. Thanks for watching. Bye bye.